So in security, job zero is knowing what you have, right? It's knowing what systems and services you have, and ideally, it's knowing how they work. Because if you don't know what systems you have, then you're not going to apply the investments and the time you have for security in the right places. And if you don't know how your systems work, then you're probably not going to put the right controls in place. So the goal of my talk today is really to talk a bit about that problem and how that affects cloud-native stacks specifically, and some of the things that we can do when we're deploying applications in a cloud-native fashion to improve that problem. I also want to talk about observability and how the modern practice of observability, which is getting a lot more traction in IT, actually, I think, can improve security and can actually help us improve how we do our security task and improve how we know what we've got and how it works, thereby improving our security. So briefly, before I get started, a little bit about me. My name's Rory. I am a senior security advocate for Datadog. I've been in security for information, IT, cybersecurity, whatever we're calling it this year, for a bit over 20 years. And I've done a number of roles around as an information security analyst, threat modeling systems, and also as a web application security pen tester. I've tested a lot of applications over the years. These days, I do a lot with cloud-native security and sort of things like Kubernetes and Docker. But I've had an opportunity to kind of see a lot of how security observability works or doesn't work. And what I want to talk about in today's presentation is essentially some of the things that I've learned over that time. So before we get started, let's have a quick look at the agenda. What I want to talk to me, we're going to start with looking a little bit at cloud-native security observability. So when we're deploying applications in a cloud-native way, we're using containers, we're using cloud, we're using microservices. What does that mean for security observability? I want to focus on application security observability specifically. And that's what we're going to spend a lot of time talking about today. And then OpenTelemetry. So the OpenTelemetry project has been, again, growing in prominence. And I think, and what I'm going to talk about as we go through this talk today, is there's a lot of opportunities for security in OpenTelemetry, which isn't something that people are necessarily taking advantage of yet, but hopefully they will. And then we're going to finish off by looking a bit at application security management. So first things, though, the defender's dilemma. So in security, there's generally held to be a thing called the defender's dilemma. And the defender's dilemma goes, an offender must be right all of the time, and the attacker needs only be right once. So the idea here is if an attacker can find a single misconfiguration, a single set of stolen credentials, a single vulnerability, that they can use that to start compromising someone's systems, and then from there trying to steal their data, expand their access, do whatever it is that their goal is. But the defenders have to be right all of the time because they've got to protect all of those systems, right? And therefore, as we get more and more services and as we get more and more systems, this becomes harder to do. So it's fair to say, and I'm sure everyone has experienced the idea that we now have more applications, more web services, more cloud services than we had maybe 5, 10, 15, 20 years ago. Therefore, it's harder and harder to prevent all of the attacks. And indeed, looking at cloud-native stacks, there's a lot of complexity there, so that adds to this problem. Indeed, I think at the moment, preventing every single attack all the time, probably an unrealistic goal. But I would say that there is essentially a counterpoint, a flip side to the defender's dilemma. And I call that the attacker's dilemma. So the attacker's dilemma goes that the attacker must avoid all of the detections that are in place, whilst the defender only needs to detect the attacker once to be able to start responding to that attack, to be able to then kick the attacker out of their systems and secure whatever vulnerability has been exploited. And the idea here is that essentially the more detections we have in place, the more opportunities we have to detect the attacker. And if we notice that they're doing something, and we can actually then say, okay, that is something, a vulnerability that's been exploited, we can start responding to that and start then kicking them out. So here, if you think about how attackers work, maybe they start with an application vulnerability, and then they break out to a container. From the container, they try to get to the host. Then they expand their access. And we've seen this a lot with real-world attacks. they'll try and expand their access to cloud APIs or to containerization APIs like Kubernetes. Each of those represents a point where we could have detected the attack if we have detections in place. So that gives us an opportunity there. The more systems we have, potentially the more detection points we have. But where does observability, because I want to talk about observability, where does observability come into this? Well, observability has been a growing practice in IT. If you've noticed, you ever go to KubeCon, Cloud Native Foundation's conference, they have a dedicated observability day, and that's been running for 2 years now. So this is something which has been getting a lot of traction in the wider IT organizations. And I think that it has the potential to really benefit security organizations. But before we kind of dive into that, we have to talk about, well, what is observability? So at the moment, there are quite a lot of definitions. I don't think, like a lot of terms in IT, there's a lot of debate about exactly what the term means. This is a definition of observability that I got from the OpenTelemetry website. This is how they define it. And it goes, observability lets us understand a system from the outside by letting us ask questions about a system without knowing its inner workings. Furthermore, it allows us to easily troubleshoot and handle novel problems, unknown unknowns, and helps us answer the question, why is this happening? Now, as a security professional, when I first read this definition, I thought, that's fantastic, because they're literally describing the problems that security people have. We tend to sit outside systems. We don't always have access to the running code. We're not always sitting inside the system as security analysts or as pen testers. So being able to look inside a system from the outside and understand its inner workings is very useful. And then, what is more of the definition of an unknown unknown than an attacker? We don't know when they're going to turn up, and in a lot of cases, we don't know what they're going to do. Because if we knew that, we would have stopped them from doing it, right? So if we, by making systems observable, we can help ourselves answer these kind of questions, I think that is a huge benefit for security. And as more systems become observable, I think there's more of an opportunity for us to leverage this. So that is what observability is at high level. We should talk a bit more about what that means in detail. That's kind of a fairly abstract and kind of high-level concept. So I thought I'd look briefly at security across the cloud-native stack, or security observability. This is based on a document from the Kubernetes website, which is called the 4 C's of cloud-native security. You might have noticed there's one additional layer in there, and you can probably work out which one it is because it doesn't start with C. But I wanted to add that because I think it's important. So there's lots of different layers in a cloud-native stack, and each of those layers has its own opportunity to produce information that could be useful to us for security observability. At the code layer, we've got traces, metrics, and logs. I'm going to come back to that because we're going to focus on that in the later part of this presentation. But then we've got the container layer. So containers, we're running a lot of our applications in containers now. We're using Docker maybe in development. We're using Containerd or Cryo in production. And containers and container runtimes generate log entries. And they also have metrics. So log entries could tell us things like what containers are being launched on a host. What images are those containers using? There's lots of potential for information that could be useful to us for observability. But also things like metrics. So metrics like how many containers are being launched a second. You know, if someone starts launching 10,000 containers in your environment that you weren't expecting, it's a fair bet that something's going wrong there. Or maybe CPU that a container is using. You know, classic attack is crypto mining, and crypto mining, the main detection that you will notice is the CPU goes up because that's what they're using for their purposes. So containers generate a good source of information for us. But then we have host, which is the one I added. And the reason I added that is my background as a pen tester. As a pen tester, if I'm attacking a containerized environment and I break out from a container, so I get an application vulnerability, I break out of the container, I get to the host. And the host is a great place for me as an attacker because I can leverage that to expand my access, to try and look for other things. And it's also a great place to persist attacks. So if you want to stay for a long period of time, a host is a much better place than a container because containers come and go. They're ephemeral. So hosts are very important, and they have, again, logs that are generated from them and metrics. So gathering that information, I think, is very important, and one of the detections we'd use. Then underneath that, we have the cluster. Now here, we're probably talking Kubernetes, because most of the time when you're running container orchestration, you're running Kubernetes. And there's a couple of sources of information that are super important to get security observability here. You'll notice that for most of these layers, I put quite generic because it is variable depending on what you're doing. But I have got one very specific one here, which is Kubernetes audit logs. If you are running your applications and your services on top of Kubernetes, please make sure you have the audit logs turned on. If you don't have the audit logs turned on, there are lots of things attackers can do that will leave absolutely no trace anywhere else in your environment. It's a slight divergence from this talk, but I did want to mention it because I think it is very important. If that's something that's of interest, I can point you at another talk I did about getting persistence in Kubernetes clusters, and there's places there that you really need audit logs. So Kubernetes audit logs, which if you're using GKE, obviously is great because they get turned on by default. But do also make sure you're looking at your audit logs, because if you don't look, you won't find out what's in there. And then lastly, but very much not leastly, we have the cloud. Cloud underpins all of these layers, and again, generates information that can be useful to us for gaining observability in our environments. So there's lots of opportunities there, but there's two other things we need to know if you're doing security observability in cloud-native stacks. There's two things you need to take care of. One is correlation, and I will mention correlation a couple of times through this talk because it's critically important. If you just gather all of that, like you literally just dump that somewhere, it's not much use. Because how do you know what log in a code went to what container, went to what host, to what cluster, to what cloud account? You don't. You just have these big piles of information. So making sure your information has the appropriate tagging and correlation added as it's gathered is super important. The other one is you need to remember about ephemerality. Right? One of the key things about containerized environments is containers come and go. Hosts may come and go, depending on how you've got things like autoscaling set up. Even clusters might come and go. Things are not there. And if I'm investigating an attack an hour, a day, a week after it might have started, I need to make sure I've moved all the information away into a centralized location because those containers don't exist anymore, in all likelihood. And I won't still be able to go back there the way I maybe could in the old days where you could go and look at logs that were a long time old. You can't do that anymore. So ephemerality is really important when you're doing this kind of work, making sure you put things in a central location. So I wanted now to talk a bit about and focus on application security observability. And there's a kind of good reason for that. As I mentioned earlier on, my background, I did a lot of web application pen testing. And so I'd come up to an application. I'd generally sit in a black box fashion for most apps, and I would run my attacks and run my tests. And a common question that customers would ask me is they'd say, are you still working, or what are you doing, or have you finished yet? And I thought to myself, quite often, do you not know? Are you not actually seeing what I'm doing? And therefore, you can tell what attacks I did, and you can tell when I finished. And the answer in most cases was no, you couldn't. And I think that's traditionally because instrumenting applications for security is seen as being a bit tricky. It's seen as being cumbersome, it's seen as being requiring a lot of effort. And I think as a result, a lot of people don't do it. So it's definitely, of those layers I showed you in the last one, I personally think that that application layer is the least explored and the least kind of set up to work for security. And fortunately, I think with modern observability tooling, it's actually very simple. And I'm going to show you what I mean by that. I actually think it's quite simple to do this. So I mentioned I was going to come back to this earlier on, and I want to talk about application observability. What does it mean to make an application observable? What information do you need to generate to have that property that we talked about with the definition that we had of observability? And there are essentially three main sources. Logs, log information, right? Anyone who's ever used an IT system for any length of time, you're familiar with logs. Your code or your system generates structured information about what is going on in the application, right? So we need that because that might give us useful information about what happened. That tends to typically depend on the application code, having logging added to it, or mainly maybe a programming framework or programming language would also generate logs. But logs are very important. We then have metrics. So metrics are essentially anything which can be assigned a numeric value which changes over time, and it can be stored in a time series database. So this could be simple things like memory usage, CPU usage, network usage. All of these can be set up as metrics. But it could also be things that relate specifically to your application. So for example, how many users are logged in? How many users are logging in per second? You know, a good application metric is, well, suddenly 500 users per second are trying to log in when previously it's been only like 2 or 3 a second. At that point, you can fairly safely say someone's trying an account takeover attack on my system. So that kind of stuff can be stored in metrics and be very, very useful for security. But then the last one, I'm guessing, is less familiar to people from a security perspective and also more generally, which is tracing. And tracing is vital where you are dealing with distributed applications, things like microservices apps. So if you have a microservices application and a user does something like add something to a shopping basket, that then goes through multiple different discrete services of code. If you can't correlate that information, troubleshooting is real pain because I can't work out where the errors that were generated in one service relate to what was happening on another service. So the idea of distributed tracing is you can add an identifier to data as it passes through all of your distributed systems, and that allows you to correlate and say these individual invocations of a service related to this higher level request. So we can actually work out what's going on. Now that's great from a troubleshooting perspective, obviously, and a performance management perspective, but also amazingly useful for security. Again, I go back to my days as a pen tester and think if I had access to that, it would be so much more useful because I could see where the errors I was getting when I put various attacks in were actually occurring. And then lastly, obviously, I said I mentioned this a couple of times, correlation is so important, okay, especially in distributed application. You've got to be able to correlate your logs, your traces, and your metrics in order for that to really work. So let's do a little demo just to kind of show a little bit what that looks like. So I am going to go here, and then I'm going to pull up a trace. We've got a trace. So this is a trace. This is from a demo application, which is an e-commerce shopping cart application. And I just want to show a little bit what that looks like. You can see here we've got the overall action, which in this case was checkout. A user was checking out. And then what you can see is that all of these different colors are different services. The authentication service, the Mongo database service, a payment service. But each of those things and each of what happened and what functions were used, how long did it take, is all correlated together. Because without this, you'd have a whole lot of different sources of information, and you'd have no chance of working out which thing relates to which thing. But you also get correlation down with things like logs, so we can see what logs were generated when that application happened. So we can see what happened. If you get errors, for example, we can see we've got an errors tab as well. We can also see metrics. So you can see, again, if this generated some massive metric, like, for example, I was trying to do denial of service, you would see a metric where it would spin up something like CPU. You'd have evidence in the metric that this request caused this problem. And then also you get some kind of fun stuff. You can also correlate it back to SQL queries. So you can say, here are all the queries that were generated as a part of this. And again, from an app security perspective, if someone's doing SQL injection, it's super handy to see what queries they generated because that's a really good indicator that that request was attempting to exploit a SQL injection attack. So having an observable application, even without any additional kind of things added onto it, really does allow us to start working up and actually making sense of what's going on and being able to track back and answer those unknown unknowns. You can go back to that trace a day after it happened and find all that information and say, what happened yesterday, whatever time it was. So that's done for that demo. We'll go back to the slides. Where are we? Cool. So now I wanted to talk a little bit about OpenTelemetry, because that's where this kind of leads. For people who, I don't know if you've encountered OpenTelemetry before, but a little bit of background about what it is. OpenTelemetry is a relatively young project. It has been going since 2019, where it was the merger of the Open Census and Open Tracing projects. And the idea of OpenTelemetry is that it provides a vendor-neutral API and SDK for observability. So it provides support in a large number of languages for applications to be made observable. And this is kind of exciting because it means that far more applications will be made observable by default. So if you think about it, if I'm making an open source project, I mean, everyone uses large quantities of open source projects in their environment. If I'm going to be the person writing that open source project, I'm obviously not going to add observability for a specific vendor, right? Because I don't know who all my users are. I don't know what observability tooling and stacks they're using. What, however, I will do is add an open source observability tool and actually embed it in the code as I'm writing the open source project. And we've seen this already starting to happen in the kind of container stack, which is where I spend a lot of my time. A lot of the components have added OpenTelemetry tracing. So for example, Kubernetes API server now has tracing. So you can turn on tracing in Kubernetes. Containerd has tracing. Docker has tracing. etcd has tracing. It's fair to say that a large number of open source projects and growing are adopting OpenTelemetry. And this potentially has benefits for security, because this is making these systems observable out of the box. You don't have to add anything in. As soon as you install them, there's generally a flag or an environment variable you set, and suddenly you've got trace information. And that's increasing the quantity of information, and again, giving us another potential location for detecting attacks. So OpenTelemetry is kind of taking off, and I very much hope it does take off. So a little bit more about OpenTelemetry, just to give you an idea of how it's getting on. This is a statistic that the Cloud Native Computing Foundation produce every year, and they talk about what are our most active projects. And you can see, obviously, unsurprisingly, Kubernetes is number 1, but OpenTelemetry is number 2. So this is the second most active project in the Cloud Native Computing Foundation. And I'm personally seeing, from what I've seen, a lot of teams saying we'll embed OpenTelemetry. Definitely a lot of open source teams saying we will embed OpenTelemetry because we want, obviously for troubleshooting, observability is fantastic. So they're putting it in for observability and troubleshooting purposes, but I think there's benefits here for security as well. And we'll see more of this because you don't get to be that active and not get people to be doing more of it. So OpenTelemetry, I think, has a lot of benefits for security potentially. What does it look like? I'll give you a very basic idea of what an architecture for OpenTelemetry might look like. Essentially, your applications add a tracing library. So what they're doing is they say, OK, I'm going to actually add this tracing library, which allows me to generate traces and also export logs and metrics. You then send it to a collector. So there's a thing called the OpenTelemetry collector, and this will gather the information from different applications. You can then transform the information inside that collector. So things like redacting specific information or adding tags. So some of that metadata that you need for correlation can be added to the collector. And then you send it to backends. And backends can be anything which supports OpenTelemetry. And there's a large number of backends. There's open source backends. There are commercial backends. Obviously, Datadog supports OpenTelemetry. So you essentially have this situation where you can gather a lot of information and then send it back out and actually then analyze it and look at it. And we'll do that. Let's do a little demonstration and actually look a little bit at that. So where are we? What I've done here is I have got actually, I'll just show you what I've got. I have got this is the OTel demonstration application, and it essentially is a microservices app, and it's designed to demonstrate what you can get with OTel. And so literally, this is a set of microservices that make up an e-commerce shop, and they have added OpenTelemetry to those applications. And you can see in our Kubernetes cluster, we've got a whole load of services, we've got a whole load of deployments, and a whole load of replica sets. So that's all fine. But that gets us some good information with adding nothing else, without doing any additional security work. The first thing you get is you get a list of all the services. And you get things like what programming language they're written in. So even with nothing else, as a threat modeling person, that's useful. And as a pen tester, that's useful. Because now I know what I'm testing, or now I know what I'm threat modeling, and I know what programming language is. Now you might be saying to me, do you not always know that? And the answer is no, you don't. As security, you're sitting outside the system. You don't always get that information. And that is not based on documentation, so it's not out of date, because that's based on live traffic. So you get that. That's super useful. But you also get another thing which I think is really handy, which is a service map. So this is without any additional work. This is just instrument and then send the data to the back end. You get a note of what services talk to what services. So for example, if I pick the checkout service, I know what traffic it communicates with. Now, if I'm threat modeling, this is amazingly useful, because this tells me if I want to design authentication or authorization controls, what I can do is I can say, OK, I know what talks to what. So I can say, hey, what is your authentication strategy from the checkout service to the email service? Also, if I want to do something like firewalling, so I want to add Kubernetes network policies to an application, which is a very good hardening step. Having this is a great starting point, because again, based on live traffic. It's not based on documentation that might be 6 months old. It's based on live traffic, so you can say, OK, I know this one needs to talk to these ones, but probably not those other ones. I can now put some network policies in place with a lot more confidence that I'm not going to break production when I do it. So having that level of observability is really useful. And then you also get the tracing information, which is very similar to what we saw before. So we get a variety of traces. And you get things like this, which show you, again, similar things. But the thing I wanted to mention quickly is some of the correlation stuff. If you see there, I've got host, so it tells me what host it was on. So I know what host that application was on. It also tells me things like what cluster it was in. And it tells me what deployment it was. So if I need to go and talk to a specific team about it, about something, an error that comes up or a security error, I know what deployment it was, I know what cluster it was, and I know what node it was. I know where to go and look for additional information. And again, that all comes just literally from having added OpenTelemetry to my application. So that's pretty useful. Now, with all of that said, At this point, I'm going to mention a couple of caveats to where OpenTelemetry is and what you can do with it from a security standpoint, because there's a couple of things you should know about how it currently works. So OTel is currently designed for performance monitoring and troubleshooting. And as a result of that, it's not specifically designed for a security use case at the moment. There's two things about that. One is what you do with tracing when you're generating and sending traces. You typically don't send every trace the application generates. And the reason for that is performance and money. Because if you send every single trace, that's a lot of network bandwidth. And then also it has to be stored in the back end, which is money. Because the more data you have in a back end, the more it's going to cost you for storage and analysis. So from this sort of stuff, you don't see that. And the other thing is, at the moment, OTel doesn't send all of the information about the request to the back end. Specifically for HTTP, it doesn't send the body of the HTTP request. Now, if you're in security and you're doing analysis for incidents or seeing what attackers are up to, the body's kind of a useful thing. You really do need it. Obviously, it's a tricky one, though, because if you send the HTTP body, you run the risks of sending sensitive PII information or other information that you don't want stored outside of the application. But right now, that's not sent. The reason I say right now is there is a project, inside the OpenTelemetry project, there is a movement to try and make OpenTelemetry do more for security, to add what's called the OpenTelemetry semantic conventions, which dictate what they have available to store and send on. So I'm hoping, anyway, that in time, OpenTelemetry will improve and we'll actually see more information. But even without additional information, I think you can see from that if you're threat modeling or if you are pen testing, that is super useful. Again, as a pen tester, that would be amazing if I could see all that information when I was pen testing. But that's where we are. So that's it for that demo. We'll go back to the slides again. And then just to finish off, talk a little bit about application security management. So like I said, at the moment, OpenTelemetry isn't perfect for AppSec. It's useful. It has its benefits. There's definitely things I think are very useful, but it's not perfect. How do you make it better? How would you improve it? Well, what you need to do to make application tracing, distributed tracing, work for security is you need to embed security understanding inside the tracer. So the tracer needs to know what's going on. Because if the tracer understands things like what SQL injection attacks look like or what command injection attacks look like, it can get a specific request that goes through the tracer. It can say, hey, that is something I think is security related. I'm going to make sure that's sampled. I don't have to worry about it being 1 in 100 samples, 1 in 1,000. I'm going to send that one to the back end guaranteed. And it can also send specific information about what caused it to think there was a security attack going on. So you need to embed that on the actual tracer inside the application. And we can look at that and how it works. So let's do the last demo. And I want to show you, actually, before I look at what it looks like, I'm going to get, where's VS Code? Here. Because one of the questions, we go back to demos. That's been nice. Switch back to my screen. Yay, here we go. Awesome. Right, so one of the things that came up when I was driving around this talk is I was talking to someone, and they said, is it not really difficult to instrument your application, to actually embed this inside the application? And the answer is no. That line there. That is what adds application security management to this application. I basically have one package. In our case, this is the data.1 DD trace, and I tell it AppSec true, because I want it to do the AppSec stuff. You can put that line into your server. You can then install the package and start your application, and it will start generating traces. So it's not something where I think there's been a kind of concern with app security, as I said earlier. I think the reason people don't do it as much is because they think it's very complicated. You get a level of tracing support here. Now, what that will give you, obviously, is generic, though, because it knows about JavaScript and it knows about Node, but it doesn't know about your specific application. So if you want to add information about your specific app, you do need to add custom code. And I can kind of give you an example. This is just a little demo application, but we had an example down here. So this little snippet of code there, what that does is basically tell the tracer what the user ID is and how to extract it. So now if I add that code to this application setup, this now says, OK, I now know what users are. And when I send traces, I'll send the user ID as well. So I'll actually send the user ID along with the trace. Again, amazingly useful for security if I can say what user was logged in when the bad thing happened. Because then I know I can contact them and say, hey, has maybe your password been compromised? Or if they're a brand new user, I can ban their account because they probably just signed up to try and attack my system. But it's not difficult. I wouldn't say it's trivial, but it is something that can be added as well. But you get a basic level of support, literally just by adding that one line. And away you go. So tracing is not too hard from that perspective. What does that look like when we get back out? So just to kind of, what does that actually look like? Let's get a trace up. So to give you just an idea of what that looks like, this is a relatively simple application. But here we can see what that looks like. We can see we have a trace here. And in that trace, it says, I know who the user was. And it also says, I have extracted from the body of this request what it was that I think was an attack. So this was a server-side JavaScript injection attack. I was essentially attacking a piece of code that very unwisely used eval on user-supplied data. And that was an attack that said, OK, you're trying to do something bad to the app. So with relatively minimal modifications to the code, I can actually get something out here which then ties in, of course, to the wider system. And I can see all the other metadata, like what host was this deployed to, what cluster was this deployed to, and everything else. So there is a good opportunity to tie observability tooling into security relatively simply. And with that, we'll go back to the slides. So conclusions, to bring this all together. Cloud-native security observability is hard. We've got more and more systems. We've got more and more places we need to add detections. I think, however, that if you've got detections at every layer of your cloud-native stack, you get quite a few opportunities to detect attackers at each stage of what they're trying to do. And the more detections we have in place, the harder their job, because they've got to avoid us every single time. Application tracing, again, I think represents a really good way, a really good opportunity for us to improve security observability. Now, as observability becomes more prominent and as more people are deploying it anyway for other reasons, security people can essentially leverage that and try and actually, make benefit out of it. And you can also work with existing observability tooling. Even if you've not got specific dedicated security-focused observability tooling, just ordinary observability tooling has significant benefits for security teams. Things like knowing exactly how systems are architected, how systems are put together, what languages they use is very useful information. So working with existing observability tooling lets security teams get quick visibility, lets us answer that question that I posed right at the top of the talk, which is, how do you know what you've got? Well, observability, I think, is a decently large part of the answer to that question. And if I had a call to action, something you might want to do after this talk, if you're in the talk audience and you're in security, go and talk to your IT teams. You might well find they already have observability tooling deployed across a wide range of their applications, and work out what benefits you can get from that. Do they have an OTel project? It's entirely possible they have an OpenTelemetry project already. You can leverage that to get more information. And if you're on the other side of the fence, you're in a DevOps team or an SRE team or an ops team, go and tell your security teams that you've got this stuff, because they might want to know. It might be really useful for them to understand that. So hopefully, that kind of gives you something to take away from the talk. Where do we go? Yes, feedback is greatly appreciated. If you have time, very much obviously appreciate feedback. If you have any questions about the talk, I'm around all day. If you have any questions on the product side of things, I will direct you to my colleagues on the booth. The Datadog have a booth where they'd be happy to talk to you more about this as well. And I think we have a little bit of time for questions. So if you have any questions now, please do let me know. If you put hands up, we have mics. Or are we good? Oh, yeah, sorry, champ there. We got a mic for the... Mic's on its way.
Yeah, so was that JavaScript we were looking at where the library was, the AppSec library was included with the one line?
Yeah, so that's a Node.js application. So I think one of the things you do need for tracing, obviously, is language-specific support. But yeah, OpenTelemetry and definitely Datadog support a wide variety of common application languages. So yeah, that one was Node.js.
Sorry.
You're back.
Do you have recommendations for other languages, if it's that easy to include? Java, Go?
It's typically for most of the languages. I hesitate slightly because there's so many different frameworks and languages. For most of them, you can get a basic level of support. So you get generic support just by adding the library and embedding it, because then it understands the semantics of how Java does HTTP or how Golang does HTTP. If you're doing something in very unusual languages, then it might be tricky. But there is pretty wide support. OTel and both Datadog, I've got fairly good support. And it should be fairly simple to get that level started, with more customization possible, actually, on top of that. Any other questions? Or are we good? Awesome. Well, thank you very much for your time, and I hope that was helpful.